Dear students, good morning. Today we discuss about database management system in database architecture. Myself, S. John Paul, Assistant Professor, Department of Information Technology, Tech Multitech, Dr. Rangarajan, Dr. Sagundala Engineering College, Avadi, Chennai. Today we see the topic database architecture. The database architecture is a collection of components. The components has number of modules. Each module has some responsibility. The functional components of database system mainly divided into two major components. One is a storage manager, another one is a query processor. The database architecture has a number of modules. Each module has some responsibilities. There is a four types of database user. One is a Navy user, application programmers, sophisticated users, specialized users, database administrator. The database user and administrator, the primary goal of database system is to retrieve the information from and store new information in the database. People who work with a database can be categorized as database user and database administrator. The database user, how to interact with the database. The database user is a person, how to interact with the database. So they are divided into four types. One is a Navy user, application programmers, specialized user, sophisticated user. The Navy users, they are the unsophisticated users who interact with the system by invoking one of the permanent application programs that have been already previously written. The type of user interface for Navy user is a form of interface. Just their user can fill the appropriate field in the form. For example, suppose you are reserving any railway ticket, just you have to invoke the IRTC site. So there is one application form is open. It needs some information. You have to fill what are the details are asked. For example, people accessing database over a web, bank tellers, clerical staff. Next one is application programmers. They are the computer professionals who write application programs, use the database. These application programs are written in programming language like COBOL or programming language Java or fourth generation language like C, C++, Python, any programming language. These programs meet the user requirements and made according to the user requirements, retrieving information, creating new information, and changing existing information is done by this application. Next, another one is a sophisticated user. These user interact with the system without writing any programs. They do not use any application programs to request the database. They directly interact with the database by means of query language like SQL. These users will be a scientist, engineers, analysts who thoroughly study SQL. Who are all know SQL commands, they are by using the SQL commands, they are interact with the database by SQL queries. Next is a specialized user or sophisticated user who write specialized database application that do not fit into the traditional data processing framework. For example, computer-aided design systems, knowledge base and expert system, and the environmental modeling system use complex data types. Next, database administrator. The database administrator is a person. One of the main reasons for using database management system is to have a central control of both data and the programs that access those data. A person who has such central control over the system is called a database administrator. Database administrator is a person who has the central control over the database. That is called a database administrator. The functions of that database administrator include schema definition. The database administrator creates the original database schema by executing a set of data definition statements in the DDL, data definition language. Next, the storage structure and access method definition. Next, schema and physical organization modification. The schema, the database administrator carries out of changes to the schema and the physical organization to reflect the changes needing of the organization, to alter the physical organization to improve the performance. Next, another responsibility is granting of authorization for data access. By granting different types of authorization, the database administrator can regulate which part of the database various users can access. For example, there is a many users are available. So which user can access which part of the database? It is monitored and controlled by the database administrator. The authorization information is kept in the special system structure that the database system consult whenever someone attempt to access the database in the system. Migrate database servers. Another one responsibility is the migrate database servers. Sometimes users using Oracle would like to shift SQL Server to NetSA. It is the responsibility of database administrator to make sure that migration happens without any failure and there is no data loss. Next, another one responsibility is the routine maintenance. The database administrator main responsibility is the routine maintenance activities. That means periodically backing up this database either onto the tapes or onto the remote servers to prevent loss of data in case of disasters such as flooding, natural earthquake, or fire. These are the disasters. So you have to secure your data. It is mainly backing up data periodically. Next, another one is ensuring that enough free disk space is available for normal operations and upgrading disk space are required. Monitoring jobs running on the database and ensuring that performance is not very expensive task submitted by some users. Next, another one database architecture, the disk storage. The disk storage are used to store all data information in the disk storage. The various components of disk storage data has data files which stores the database itself. Next, data dictionary, it contains metadata, data about data. Next, scheme of table is an example of metadata. A database system consults the data directory before reading and modifying the actual data. Indices, it provides fast access to data items that holds particular values. The statistical data stores information, statistics of data records. The storage manager is a program module that provides interface between low-level data stored in database and application programs and queries submitted to the system. The storage manager is responsible for the interaction with the file manager. The storage manager translates DML statements into low-level file system commands. The storage manager is responsible for storing, retrieving, updating data in database. The components of storage manager. The storage manager has 4 components. One is a authorization and integrity manager, transaction manager, file manager, buffer manager. The authorization and integrity manager are responsible for check authority of users accessing the data. The unauthorized access is restricted. Those who want to access the data, they have to check if the user is correct or you are a authorized user or unauthorized users. Verify the user details, then only they have to allow to access the data. To test integrity and constraints of data. Integrity means there is some set of conditions. Based on the condition, then only the data will be stored in the database. The transaction manager ensures that the database remains in a consistent state despite of failure. In case of any failure, there is a data will be transferred, then it will revert to its original position. Next, another one is a concurrent execution is maintained without any conflict. The file manager are used to manage allocation of space on disk storage. Information stored on disk is represented using database. The buffer manager is responsible for fetching data from disk storage into main memory. It decides what data to catch the main memory. Next, another one is a query processor. The query processor is an important part of the database system. It helps the database system to simplify and facilitate access to data. The various components of query processor. DDL interpreter. The DDL is a data definition language. It is used to create structure of the table. Interpreter is a translated converts. It converts DDL statement into machine understandable language. For example, it interprets DDL statements into low level. That means machine understandable language. Next, it records the definition in the data dictionary. Next, DML compiler. It translates DML query statement into query language. Query evaluation engine understand only low-level instruction. Query can be translated into many number of evaluation that can be produced the same result. The query optimization is picking up the lowest cost evaluation. There is a many alternatives. It is performed by DML compiler. Query evaluation engine execute low-level instruction generated by the DML compiler. The database architecture can be divided into 2 types. One is a 2-tier architecture. Another one is a 3-tier architecture. The 2-tier architecture, usually database application is partitioned into 2 parts. The 2-tier is based on client-server architecture. The 2-tier architecture is like client-server application. The direct communication takes place between client and server. There is no intermediate between client and server. The user wants to access data without using any intermediate. That is a 2-tier architecture. Only there is a client and server applications. Client has client application, server has database system. So the client directly access the database through the networks. That is the architecture of 2-tier architecture. The client application run on a client system. The server system has database data sources. Next, there is a three-tier architecture. In the three-tier architecture, there is an intermediate between client and server. Client has application client, server has application server. The client want to access the any data from database. It requests to the application server. The application server is an intermediate that get the data from database system. Then the data will be produced to the user. In the three-tier architecture, client machine act as a front end, does not contain any direct database calls. Instead of client can communicate with the application server. The application server in turn communicate with the database system to access data. Three-tier architecture typically comprises a presentation layer, business or data access tier, and a data tier. Three layers in the three-tier architecture as client layer, business layer, data layer. The client layer, it is also called as presentation layer, which contains UI part of our application. This layer is used for the design purpose, where data is presented to the user or input is taken from the user. For example, designing registration form which contains textbook, label, text box, label, button, etc. Business layer. In this layer allow business logic written like validation of data, calculations, data insertion, etc. This act as an interface between client layer and a data access layer. This layer is also called the intermediary layer, helps to make communication faster between client and a data layer. In the data layer, in this layer, actual database comes in the picture. The data access layer contains methods to connect with the database and to perform insert, update, delete, get data from database based on our input data. Next, another topic, introduction to relational database. The relational database the database system is basically a record keeping system. Collected form of data is known as database. Database is actually a collection of interrelated data so that it can be used by various applications. Some of the popular database softwares are MySQL, it is a open source, Oracle database, MySQL server, SQLite, which is a open source, MariaDB, PostgreSQL are the open source. The relational database model, data remains in the form of tables. A table is a combination of rows and columns, which is also known as relation. In a table, a row shows a relationship between values. A table is a collection of this relationship. Imagine a database has three tables, supplier, item, and shipment. The supplier table has some of the attributes: supplier name, supplier number, status, city. The item table has some attributes: item number, item name, price. The shipment table has some of the attributes: supplier number, item number, quantity supplied. There is an example of relational database model. Supplier table has supplier number, supplier name, status, city. It has some tuples, some values. Item table, same as item table, has some of the attributes and the values. Shipment has some of the attributes and values. The components of relation. In this table has supplier name as a primary key. The supplier name number is a primary key. Supplier name, status, city are a field. It has some values. It is called as a record. There is some number of individual domain is called a data item. The relation model has some terminologies. The relation model was given by E.F. Code of IBM. Relation, basically, a relation is a table. It is a collection of data in rows and columns. A relation has following features. In a table, data in one column should be same data type. Different columns can have different data types. The value of each row and each column should be atomic. A column in row cannot have multiple values. In a relation, each row is distinct. Any two rows cannot have exactly same data. There is no specific order of rows in a relation. In a relation, there is no specific order of columns. Relation model has some terminologies. Domain. The pole value of column is known as domain. The row of table are known as tuple. The column of a table are known as attributes. In a relation, number of attributes or column is known as its degree. In a relation, number of tuples or rows is known as its cardinality. The database has number of attributes. The sum attributes has, you have to set some properties. It is known as keys. The primary key, it is a group of one or more attributes which are used to uniquely identify records of a relation and can be used to establish relationship with other relation. It is a mixture of unique constraints and not null constraints. Unique constraints is there is no duplicate of values. Not null constraint has compulsory values. In general, all master tables have primary keys. For example, employee code in employee table. Student number is a student table. The candidate key, it is a group of attributes which have the properties to be selected as a primary key. These attributes shows their candidate to be a primary key. Each table has only one primary key. Suppose if I use another one attributes as a same property, it is called as candidate key. Alternate key, a candidate key which is not a primary key is known as alternate key. Foreign key, a table, a non-key attributes which is derived from primary key of some other table is known as foreign key in present table. Referential integrity. The referential integrity is a system of rules which is used by a DBMS to ensure that there is a valid relation between related tables or not. The referential integrity is possible only when following condition gets completed. Primary key should have unique index. Related field should have same data type. All tables should be a same database. The primary key of master table should have a reference with a foreign key of transaction table. Entry of that record in transaction table is not possible whose foreign key value does not exist in primary key of master table. Deletion of that record from primary key table is not possible which has a related record in foreign key table. Change in related records of primary key is not possible. Next, another topic is a relational algebra. The relational algebra is a procedural query language. It consists of set of operations that take one or two relations as input and produce a new relation as a result. The operations enable a user to specific basic retrieval request or queries. The fundamental operations in relational algebra are select, project, union, set difference, Cartesian product, rename. The select, project, and rename operations are called unary operations because they operate on one relation. The other three operations operate on pair of relations and therefore called it is a binary operations. The unary operations select use the symbol sigma, project use the symbol phi, rename use the symbol rho. The select operators are used to select based on some condition. In the selection, we have to use the symbol sigma, selection criteria, that is a condition, predicate, and the relation name is input. The selection operation to fetch rows or tuples from a table, that is a syntax sigma select by using the symbol sigma, predicate, that is a condition, it is a relation name. Example, select the employee tuple whose department number is 4. While here we are using the condition department number equal to 4. Select, we have to use the symbol select sigma. Condition is department number equal to 4 from the relation employee. Select the employee tuples whose salary is greater than $30,000. Here the condition is salary is greater than 30,000. So we have to use the symbol as sigma. Condition is predicate salary greater than 30,000 employee. Next, another one example, select the instructors in physics with a salary greater than 90,000 and salary select the instructors in physics with a salary greater than 90,000. There is a true condition we are using. Instructor name. The instructor name is a physics and salary greater than 90,000. Department name is physics. Condition is department name is physics. Salary greater than 90,000. Relation name is a instructor. Next, another one operation is a projection. Projection operation, we have to use the symbol phi. We have to project some particular field from the relation by using the projection. For example, there is a table. Student table has student ID, student name, rating, age. There is some values. We have to project the age 50 S2. Table name is S2. So we have to display the age 35, 55. Next, another one example, to list each employee's first and last name and salary. Then we have to use project. We have to use the symbol project. Last name, first name, salary from employee. Next, we have to composition of relational operations. There is a table, yes, student ID, student name, rating, age. We have to project some particular field, yes, name, rating. The rating is greater than 8. So we got the output, yes, name, rating. Who are all getting rating is greater than 80. Then we have to show the supply yes name, student name. Next, another one operation is a rename. The rename operation row can be used. We have to use in rename as a relation name. We have to change the relation name or column name, that is attributes name, or both relation and the column name. By rename is a we have to change the old name to new name. By using the rename operation, by using the symbol phi, we can change the relation name or change the column name or change the relation and the column name both. Next, another relational algebra operations, binary operations are union, intersection, set difference, Cartesian product. The union operation is a binary operation denoted by the symbol union. The result of R relation and union S relation is a relation that includes all tuples that are either in relation R or in relation S or in both relation R and S. Duplicate tuples are eliminated. The two operand relation R and S must be type compact. That is, all attributes have same types. The condition of union operation relation R and S should have same attribute. Both have same number of columns. Name of attributes and the domain type are same in both. For example, in union, there is a S1 and S2, there is a two relation. S1 has SID, SName, rating, age. S2 has same attributes, SID, SName, rating, age. We have to combine both relation S1 and S2. We get all the field in first table. The duplicate in second relation, the duplicates will be eliminated. In second table, 31 is SID 31 can be removed. Remaining 58 can be removed. Remaining 44 and 31. 44 and 28 will be displayed in the union. Interaction is denoted by symbol. The result of the operation R intersection S is a relation that includes all tuples that are in both R and S. The attribute names in the result will be the same as the attribute's name in R. The two operands relation R and S must be type compatible. Both table has same field, then that will be displayed in the intersection. In set difference, it returns the relation instance containing all tuples that occur in R but not in S. R and S must be union compatible. Scheme of the result is the scheme of R. The set difference, the 22 is not in S2 table. That is the output of the set difference. Cartesian product operation denoted by symbol X. It is also known as product or cross join. Notation R cross S combines tuples members of one relation to other relation. Same as matrix multiplication. Consider the example, there is a relation R and S. R relation has A and B attributes. S relation has C, D, E attributes. So we get the output R cross S, R Cartesian S. We get all the outputs. SQL built-in functions. SQL has numeric function, absolute N returns. So we discuss about some important topics in database management system. So it is very useful for you. Thank you.